Morning everyone, I am Nandini Ramesh Kota. Today I am going to explain a key concept used in compiler optimization called next use information. This is a technique used during the code generation phase of a compiler to make code more efficient. Let's begin the topic. Next use information. This is the definition of next use information. Next use information tells us two important things about variable in our code. Whether will this variable be used again later? Second one, if yes, where it will be used next. This is related to concept of liveliness analysis. A variable is live if its current value will be used again before being overwritten. If it is not live, its value can be safely discarded or its register can be reused. Slide 3 is this is slide 3 which tells us the purposes of next use information. We use next use information to optimize register allocation. We only keep values in register if they are going to be used again. Second one, reduce memory access. Avoid loading, storing value unnecessarily. Third one, improve code generation. Helps the compiler write shorter, faster, and more efficient assembly code. By knowing which variables are still needed, we can free up unused registers and avoid wasting CPU resources. Fourth, let us see where it is used. This this analysis is specifically used during the code generation phase of a compiler. It is applied to something called a three-address code. This is an intermediate representation used by the compiler. We typically apply next use information within a basic block, which is a straight line section of code without any jumps or branches. Let us see algorithm steps. These are the algorithm steps of next use information. First, start at the last statement of basic block because next use information follows the bottom to up backward analysis. For each instruction, x equals to y opz. This is the syntax of three-address code. And attach lookup current liveliness and next use from the symbol table. Update the table x not live, no next use, and y and z live, next use equals to current line. Input and output. This analysis takes a basic block as an input written in three-address code. The output is nothing but each instruction annotated with the liveliness of all variables. Then next use which line they will be used next. This helps the compiler make smarter decisions about register use. This is a symbol table syntax of symbol table of three-address code. X is being assigned a new value. So the old value of x is now useless. It won't be used again. So therefore x is marked as a not live and no next use. This tells us the compiler that can be safely free up the register storing the old value of x. Y is put as a live and next used as a I. Because y value will be used again and again in the expression, that's why it put live, and I is nothing but the current line of the expression. Z is put as a live because z is also going to use a current expression again and again, and I is marked as the current line where it is used. So let us see the y set to not live and next use. So this is the explanation whatever I said. Let us see one example. The given example is a three-address code. First line is t1 equals to a plus b, t2 equals to t1 plus c, d is equal to t2 plus 1. Let us see the symbol table. After line 3, we are going to backward analysis. So first see the line number C, that is d equal to t1 plus c. Here t2 is live because t2 is the right hand side of expression. It is going to be used in current line, so it is live. And next use, it is in used in third line, that's why next use put as a 3. D is the defined just only for defined, so no live because it is going overwritten, and next use no next use of D. So let us see after line 2, T2 equals to T1 plus C. Line 2 is a T2 equals to T1 plus C. T1 and C are used to mark them live because T1 and C are the right hand side of expression. This is going to be used again and again. Yes, that's why we put yes live as a yes, and where it is used. I next use is nothing but current line where it is used. So we put as a 2, and T2 is going to overwritten by each expression. So live is nothing but no, no next use, that is dash. After line 1, T1 equals to A plus B. A is put as a yes, that is live. B is also put as a yes, that is live. And where it is used, that is line number 1, because these expressions are going to be used again and again, and also it is used in line number 1. So that is marked as a yes and 1. So T1 is marked as no live, because T1 is always get overridden by after new expression, and no next use of the T1. Let us see the final symbol table of this example. This is the final symbol table. In this symbol table, first column is variable, second column is a final live, and third column is a final next use. So here variable A, B, C, D, T1 and T2 are the variable which are used in our expression, and second column is say that variable is live or not. Third column is where it is used. So let us see the explanation of this symbol table. So A is live because A is used again and again, and it is used in line number 1. Um, and second one is a B. B mark as a yes, that is live, and where it is used a 1. C is marked as a live, and where it is used in line number 2. After that, D is marked as a no live and no next use. Def- it defined in line number 3, but it's never used after this, so it's not live and no next use. T1 is a no live and no next use. It is used in line number 2. After that, T1 is never used again. So after line 2, it becomes not live. T2 is live, no live and no next use. Used in line number 3. After line number 3, it's never used again. So after line 3, it becomes not live. Conclusion. Next use analysis ensures optimal use of registers, helps generate more efficient target code. Next use information helps compiler decides which values to keep in fast registers and which to discard, because it free up the space. It works by analyzing code backward, and it plays the vital role in register allocation, code optimization, and overall compiler efficiency. Understanding next use is essential for writing smarter compilers and generate faster and smaller machine code. Thank you.